Hello guys, welcome to this new video. In this video, I will introduce you the AWR Design Environment software, and also I will explain you how to do a RF simulation using this AWR software. Uh, First of all, this software is developed by Cadence, and it's a very useful software, especially for doing RF simulations. And I will first explain you the software layout. And if you can observe on your left side, actually this is the project browser window. This In this window, in this panel, you can find all the files and configurations related to your project. And if you go below, you can see three different panels. If you can click on elements, then this is where you can find all the components, RF components and circuit components that you use for your simulation. And if you go to the layout, in layout panel you can see the configurations related to the circuit layout, the PCB layout. And I will go back to project browser. Okay, in this project browser window, if you double click on this project options, then you will get this window. This is where you set up your frequencies. You need to specify which frequencies that you need to run in this simulation. That means the frequency, if you set, when you set some frequency range or a particular frequency, this simulation will run on that frequency. In here I will specify the starting frequency as 1 gigahertz, and also I will specify the stop frequency 2 gigahertz, and the step is 0.1 gigahertz. And you should make sure that this replace button is clicked, and then click apply. Then you can see the frequencies replaced with our as per our settings, and then click OK. In this software you can do several types of simulations. First, if you click on this system diagrams, in here you can do system level simulation. That means you specify each segment of your system as blocks and give the parameters to the blocks, and then you do block level simulation. And if you go below the circuit schematics, in here you can do component level simulation. That means you, in your system, you design the entire system component by component, and then you can simulate this your system. And also you can do electromagnetic simulation. Also we have the ability to do electromagnetic simulation also. In this example I will do a system diagram simulation. Before that, I like to create a new project. Go to file and the new project, and let me select no. Then go to file, then you can save the project as, and I will give a certain name, let's say test project, and click save. Now you can see the name of your project is changed in here. And okay, now I need to do a system diagram simulation. I will right click and then click on new system diagram. Now you can give a name to your system diagram. Let me specify it as a test diagram. Create. You can enlarge. Okay, now I'm going to do a simple RF simulation in this project. What I will do, I can go to this elements window, and here this is where you can find all the modules that you can use for your simulation. So I need to find some modules. Go to this RF blocks, then go to this mixers. You can get one of these mixers. Just what you need to do is just click in and drag in here, then click. Now rather I will go for another mixer. Let me select this mixer into the window and drop it and click. Then in this mixer there are several settings, as you can see, and this mixer can be changed. Perform sum. If you double click on this sum, there are two options, sum or difference. That means this mixer you can use for summing and differentiating to RF signals. I will select sum in here, and I will keep the default values as it is. And then I need to get some tones. Okay, you can click in this tone and drag it in here and drop it, then click. Now actually I'm going to use two tones. I can copy this module. We just click on this, press Ctrl C, click on somewhere else, and then press Ctrl V. Then you can place the second module. If you need to move this these parameters, you just click on there and drag. You can change the position of those parameters. Okay, now in order to connect these, you need to just click in here and then click in the other side. Similarly, click and click, then it will be connected by the wires. Now as you can see, these two tones have some predefined values. I will keep this value as 1000 megahertz and change this frequency to 2000. Okay, now I need to insert this port, this output port. Click on this port and click in here. It will terminate your output. And now another setting I need to do is now this is, as you can see, this is orange color. This is means it is complex form. If you move your mouse over here, you see the mouse, there's a circle coming. You just double click, then you set up this complex form, complex envelope. Click OK. Okay, now it has changed. Okay, now I need to set up some graphs to see the performance of this circuit. For that, you need to place some test points. Now you can set up some test points. If you go above, you can see this TP. Click on that, and you can place a test point in here, and also click TP. There's another test point in here. I will connect it with the wire to this, and another test point to the output. Okay, now I need to input some graphs into this simulation. I will go into this left side project browser, right click on graphs, then click new graph. I will give a name, let's say LO1, then create. Okay, now right click on these graphs right click on this LO1 and then add measurements. This is where you add the graph actually. Now for this LO I need to uh, uh, observe the frequency spectrum. I click on this system and go below, click on spectrum, and I will select power spectrum, and here I need to specify which test point that I should use. I will select TP1, then click OK. Another thing I need to mention that I can change the names of these test points. Let's say if you double click, you can change LO1, and here let's say it's LO2. This one we call out. Okay. Now I will add another graph. Right click, new graph, LO2, create, right click, add measurements. Then our previous selection, we can go for the previous selection and select LO2. In our previous setting for LO1, we need to change it. We double click and TP have to select LO1, click OK. Now there's another graph I need to add. For the this output, I need to observe the frequency spectrum of this output and also the waveform. I will right click on graphs, new graph, then call it out underscore F, create, then right click in here, add measurements, keep all the setting and change this test point TP to out, click OK. Okay, I will then add another graph, right click, new graph, let's call it out underscore V. Here in this graph I'm going to plot the amplitude of the output waveform. For that you can right click in here, add measurement, then what you need to do, click on this system and select waveform, and here you need to select the test point TP as out. Here you need to specify the time frame, time domain. I will select nanoseconds and specify the value as 100 nanoseconds, and then I will click in here to get the real values. Okay, now click OK. Now in order to run this simulation, I will first click on analyze. Okay, I will then run the simulation by clicking the button in here. As you can see, I will click this button to run the simulation. It will start the simulation. If you can observe this clock sign with the mouse pointer, that means the simulation is processing. You can minimize this window and observe the waveforms. For LO1, if you can see the value of the LO1 frequency. As you can remember, the LO1 is 1 gigahertz, and it is in 1 gigahertz. Okay, and also LO2 is set at 2 gigahertz. If you go to the LO2 graph, you can see it's on 2 gigahertz mark. Okay, now I'm going to see the graphs of this output test point. If you go to out underscore F, this is the frequency domain representation of the output of the mixer, and as you can observe, this is the frequency that we don't need because we are adding 1 gigahertz signal into a 2 gigahertz signal. That means the output should be 3 gigahertz. That means 3000 megahertz. This is what we need. We need to get rid of the other frequency components. If you observe the output waveform, and this is the output waveform, let me change the time domain setting. Go to double click on in here, and change it to 10 nanoseconds. Okay, as you can now you can clearly observe the waveform. To go back to this diagram, our diagram. Now I would like to add a filter into this circuit. For that, I just stop the simulation first by clicking. I can pause the simulation. Then I will click in here and press delete to get rid of the wire. I will drag this element out. Then go to elements tab. Then I will look for filters. In here you can find some filters. I will go for band pass filter. Okay, I will select this Butterworth band pass filter, click and drag, then click in here. Then I will change this ports to complex form. Select, double click and select complex, press OK. Then connect these wires. Okay, in here in the settings, I need to specify the FP1 is the minimum lower level of the frequency range, and the FP2 is the upper level of the frequency range. I will give this as because we need to have 3000 megahertz. I will specify 2900 megahertz. Press OK, enter, and then 3100 megahertz. Press enter. Okay, and I will add another test point in here. Now I need to change the names. I will say call it mix. I will call this one out. Okay. Now in this I will go back to the projects window. In these settings, let's double check if I need to change the. This is already replaced. Now I need to. Yeah, I can keep this as it is. I will introduce two new graphs to the output. Okay, I will rename these two. Just right click and then rename. I call it mix to say it's output. Rename. Right click. Rename. Call mix. Rename. I will introduce two new graphs. Right click. New graph. I will call it out underscore f. Create. And I will add another one. Call it out underscore v. Create. I will add the measurements. Right click, add measurements, and for this one I will click on select system, then waveform. I will select the test point to out, and time duration I will specify 10 microseconds. Select real and click OK, and then right click in here, add measurements. Then I will get the frequency spectrum. For that, select spectrum, power spectrum, then select the test point out, click OK. Now if you go back to our diagram, this is our setup. Let's see if I can get only the 3 gigahertz output in here. Okay, I will run the simulation. If you click the pause button again, it will run the simulation. It will take some time to update, and if you observe the mixer output, we can observe, as we observed in previous occasion, we can observe the various frequency components of the mix output, and then the waveform of mix output. Now I like to see the output of the circuit. That means the output of the band pass filter. If you observe the frequency domain output, as you can clearly see, now we have only the 3 gigahertz or 3000 megahertz component, frequency component available as at the output of the bandpass filter. Okay, and also if you can observe the waveform, this is the waveform of the output of the bandpass filter. In order to have a clear view of this waveform, let me change the parameters, time domain parameters. In here I will change this to nanoseconds, 10 nanoseconds. It should be 10 nanoseconds. Okay, now you can clearly see the waveform. Okay, let's go back to our diagram. Now I think you have got a good understanding about this software. And one thing I forgot to mention that this status window, you can see the status warnings, alarms, and everything will be shown in this status window. And if you can enlarge, I will first stop the simulation by clicking in here, and then I will click and drag to show you all the status messages of this window. Okay, it will help for diagnosing the faults. Okay, I think I hope you have got good understanding about this software from this video. Please hit a like if you enjoyed the video, and subscribe my channel for more informative videos in future. And thank you very much for watching, and have a nice day. Bye bye.